I'm Rebecca Weaver. I'm going to be doing factoring special products today. First up, perfect squares. Now, what are perfect squares? An example of a perfect square is x plus 3 quantity squared. That means x plus 3 times x plus 3. So what you would do is distribute your x. You'd get x squared plus 3x. You distribute your 3. You get plus 3x plus 9. And your total would then be x squared plus 6x plus 9. That's a perfect square. Note, there is a middle term. That's probably one of the most common mistakes I see is you neglecting that middle term. Remember, everything has to be distributed. So if I had x minus 3 quantity squared, go ahead and write this out so that you don't forget that middle term. So I'd multiply x times everybody, x squared minus 3x, multiply the minus 3, it'd be minus 3x plus 9. I would end up with x squared minus 6x plus 9. So let's play. Factor the following. We have x squared plus 10x plus 25. I know I need these. I need some factors of 25. 1 and 25, 5 and 5. I'm not doing anything different. I look at the pair that's going to make a 10. It's going to be the 5 and the 5. So I need an x and an x. I know my signs are going to be plus plus. I believe it's 5 and 5. You know what I got to do next? Check it. Multiply it out. I get x squared plus 5x plus 5x plus 25. Combining that like term, I get x squared plus 10x plus 25. Hey, that's right. You know what my answer is then? Cleaning it up and making it look really cool and nifty, it's x plus 5 quantity squared. And that's the way I'd write my answer. Now you could write your answer like this up here, but you see that's not near as cool as what I have written here in condensed. So let's do that. I have x squared minus 12x plus 36. You know it. Need the parentheses. I know it's going to be an x and a minus because my 36 is positive, so it's either a plus plus or a minus minus. I look at that 12, it's got to be minus minus. So then I've got to select my choices on 36. So let's look at them. Here, ooh, that went crazy, didn't it? So I wrote all those choices for 36. There's all my different factors. What's going to make a 12 would be a 6 and a 6. So I write in the x minus 6 times x minus 6. I go ahead and multiply that out. I get x squared minus 6x plus 36. Combining like terms, I get x squared minus 12x plus 36. Hey, that's right. So you know what I got to do. Write it out in the cool way. X minus 6 quantity squared. And circle it. Let's factor some trinomials with leading coefficients. Same thing. I'm not doing anything different. I'm going to look at the factors of 81. Bam. 1 and 81, 3 and 27, 9 and 9. Look at the factors of 16. 1 and 16, 2 and 8, 4 and 4. Which pair is going to make a 72? Oh my goodness, I don't know. Don't really know, but since I'm doing this factoring these perfect squares, I'm going to kind of guess that it's 9 and 9 and 4 and 4, and let's watch this happen. I got my 9x and my 9x. It's going to be a minus minus. Put my 4's at the back end. Now let's check it. 81 x squared, I'm going to have a minus 36x and a minus 36x. You know that's going to make minus 72, and my life's going to be golden here. And there is the correct answer. So what do I circle? I circle the quantity 9x minus 4 squared, because that's the cool way to do it. All right, next up is 9x squared plus 30x plus 25. You know I need those parentheses. I'm going to need some factors here. I'm going to need, oops, look at that. Okay, I'm going to need 1 and 9 and 3 and 3. Then I'll need 1 and 25 and 5 and 5. I need to make a 30. So I believe my pairs are going to be 3 and 3 and 5 and 5. So let's try this out. 3x, 3x, I need a plus and a plus. 5 and 5. Let's multiply it out and see what happens. We've got 9x squared plus 15x plus 15x plus 25. Is that 9x squared plus 30x plus 25? Well, yes, it is. That's right. Uh-huh. I'm going to write down 3x plus 5 quantity squared as my answer and circle it because that's the cool way to write it. Difference of squares. What is a difference of squares? Well, what happens is when you have the same thing multiplied by itself, but a little different, one's a positive, one's a negative, what happens is something really, really magical. You distribute that x, you'll get x squared minus 3x. Then you'll distribute that plus 3. You'll get plus 3x minus 9. Look at how those middle terms just drop. They're 0. This gives me x squared minus 9, and it doesn't even look like a regular kind of thing that I factor because that middle term isn't there. So when that middle term disappears, that's a big clue. It means it had to be the same thing twice, one a positive, one a negative. So let's play. Factor the following. All right, what we got? Got x squared minus 25. Notice that middle term is gone. So I know it's one of these difference of squares, guys. So I look at the factors of 25, 1 and 25, 5 and 5. Need my parentheses. It's got to be 5 and 5 if this thing factors at all. Remember, not everything factors. So I'm going to try an x plus 5 and an x minus 5. Let's play. X squared minus 5x plus 5x minus 25. I got a minus 5x and a plus 5x. Bam! That thing works. My answer is correct. So I circle the quantity x plus 5 times x minus 5. Let's do this again. Oh, we got a number in front this time, don't we? Well, I need my parentheses. Need my factors of 9. If this is going to work, because there's no middle term, it's got to be a 3 and a 3. Here's my factors of 16. If it's going to work, it's got to be in the 4 and the 4. If that middle term disappears, it has to be the same thing in order to make that 0. So I have 3x plus 4 times 3x minus 4 if this thing actually factors at all. So let's try it out. 9x squared minus 12x plus 12x. Look at those middle terms drop. Nice. And then a minus 16. And this thing ends up being 9x squared minus 16. You're right. Let's circle it. Now we got a little something special coming up next. It's called sums and differences of cubes. Now you really hadn't multiplied this out forwards. And these are just formulas. It's a special pattern that you can factor by using formulas. Now if you have the pattern, you can use a formula. You have to make it fit the pattern if you're going to use the formula. So for my sums of cubes, I'll do that one first. If I have a cubed plus b cubed, then it's going to factor into the quantity a plus b times the quantity a squared minus ab plus b squared. So let's see what this looks like. If we have x cubed plus 8, I have to get it in that form if this is going to work, and it's not in that form right now. Now it is, because 8 is 2 cubed. Now I know that a is x and b is 2. So I'm going to write down these parentheses and fill in with whatever is there. So it says a plus b. So I'm going to write x plus 2. Then it says a squared. So I'll write x squared. Then it says a times b. So I'm going to write minus, and then I've got to write 2 times x. And then plus b squared. And what was b? B was 2, so I write a 4, because 2 squared is 4. And that is it factored, and that's all you have to do. You just follow the formula, and you're done. No checking, you just follow the formula. You can check it by multiplying it out and watch all the terms disappear if you like, but you don't have to. This is just a formula that we're going to follow. Now, eventually in math, you could go through the derivation of these formulas and how they came about, but not right now. We're just using them. So let's say we have the difference of cubes. I got a cubed minus b cubed, and I see it's in that form. Then I can write down open parenthesis a minus b, close parenthesis, open parenthesis, a squared plus ab plus b squared, and close that parenthesis. Now my example is 8x cubed minus 27. So what I have to do is figure out what's A and what's B. So let's look carefully. I see that my A would need to be 2x. I have to get it in this form because 2x times 2x times 2x is 8x cubed. So that a is not just an x and it's not just a 2. It's a 2x. The b would be the 3. There we go. I fixed that sign for you because I was like, what? That's not a plus. That's a minus. All right. Then I need my parentheses. Then I'm going to put in wherever there is an a, I'm going to put a 2x. Wherever there's a b, I'm going to put a 3. So this is what this looks like. It's 2x minus 3 times the quantity a squared. So I've got to write 2x quantity squared plus 3 times 2x plus b squared. Well, I'm just going to do that one. That's a 9. Then I've got to write this down, go ahead and multiplying things out, make it look a little prettier. I have 2x minus 3 times the quantity, 4x squared, plus 6x plus 9. That's all that you, that's just your answer. That's actually all that you do. All right. Nice. Okay. And that's all we have for this section. Just more practice of the same thing. So if you need any help, you know who to call. rweaver10 at alaska.edu, and have a wonderful